All right, so once you understand Pascal's triangle, you may be wondering, where do the numbers even come from? So the numbers of Pascal's triangle come from the patterns formed when you expand the binomial x plus y to a certain power n, where n represents a whole number here. So for example, if I want to expand x plus y to the power of 0, anything raised to the power of 0 will give you 1. Hence the first row in Pascal's triangle. Remember, the first row is actually a combination. It's 0, choose 0. Okay, we can keep going even further here. X plus y, if we raise it to a power of 1 this time, well, you just get the same binomial. So x plus y. You'll notice the coefficients here, 1 and 1, that makes up row 2. So remember, these two numbers are combinations as well. We have 1, choose 0, and this is 1, choose 1. Okay, so notice that the numbers in front do relate back to the exponent at the very beginning here. So let's try x plus y squared. So if you FOIL it, what you'll actually obtain is this trinomial. So when you have an expansion of 2, you have 1, 2, 3 terms, okay? And that's going to be a very key pattern here. But notice the coefficients again, 1, 2, and 1. That makes up row 3, which is also a combination. 2, choose 0, 2, choose 1, and 2, choose 2. Let's keep looking here. Let's look at row 4. Which is an expansion of 3. When you expand with an exponent of 3, you get 1, 2, 3, 4 different terms. The coefficients will be 1, 3, 3, and 1, which definitely corresponds to row 4 here. And that, once again, is also a combination where n is equal to 3. Okay, so let's go down here. You get the idea now. X plus y to the power of 4 gives you 5 terms. Look at the coefficients, 1, 4, 6, 4, and 1. That gives you row 5. Okay, so these are the patterns that form Pascal's triangle. It's all dependent on what the coefficients are. Now, look at the powers of x in each expansion. You'll notice that the powers of x decrease by 1. So for example, if I look at this expansion of 4, you start with 4, 3, 2, 1, and there's actually an x to the power of 0 there, but that's just 1. We don't usually write that. So powers of x decrease by 1. So remember that pattern there. Also, powers of y, how does it change? For the first term, you won't see a y, but it actually is there. It's actually y to the power of 0. So you have 0, 1, 2, 3, and 4. So it is actually increasing by 1. So powers of x decrease by 1, and powers of y increase by 1. So we're going to use this pattern to do binomial expansions of high degrees.